Greetings. I'm going to look at doing the derivative of the natural log of the natural log of the natural log of x. We might want to recall that the derivative of the natural log is going to be equal to 1 over the interior times the derivative of the interior, which is 1, which just gives us 1 over x in this case. And we're going to do this repeatedly. This will be an application of the chain rule. When we do the derivative here, we will have the derivative of this first logarithm is going to be 1 over this log of x. Continuing with the chain rule, we have to do the derivative of the interior, so we need to look at the derivative of the log of log x, which will give us 1 over log x. And then we have to look at the interior of that and take the derivative here, so we get 1 over x. So we've done this log, we've done this log, we've done this log, and now we need to do x itself, which will be 1. And those all get multiplied together to be our derivative. And this is the derivative that we get. One of the things that's important to kind of identify when you're doing something where you have all these nested functions is to try to figure out how many functions you even have. So x could potentially be a function all of its own. Then we have to look at, we have another function in here, which is the log of this. We take the derivative of that, we get 1 over x, that's this one here. Then we have this function, which has this inside of it. It's essentially this function with this function placed inside of it. So h of x could be g of x compose g of x. I'm going to take this and put this inside of it. The derivative of this is going to be 1 over the log x. And then lastly, I have this function on the outside which has these two inside of it. So this is our last function that we're looking at. This has the log here with itself put inside of it here, and then we have this inside of this. So we could create this as a composition as well. But we need to identify that this thing is really a composition of potentially multiple functions, and that helps us kind of identify how many pieces we need to have to this because of the chain rule. And then the product of that is going to be our actual derivative here. I hope this has given you a little bit of insight at looking at what some might say could be a nested function or a function that is a composition. And then looking at the different derivatives that are going to be multiplied together to give us the final derivative that we get from the original function. Go ahead and take a look at this. See if you can figure out the derivative. Pause the video and then come back and look at a solution. All right, let's look at how to work through this. The derivative of sine is cosine. If we do the derivative of the interior here, we have 1 over x. And then if we do the derivative of x, that's multiplying by 1. And the product we get here is 1 over x cosine log of x. We could also write this so that it is all one fraction. And this will be the derivative of this. Looking at the different functions that we have our first function is sine of x. And then we place into that our second function, which is the log of x. So this here is f composed with g here. That gives us this here. And then again, we could look at x. If you want to make sure that you're taking into account to that, we took the derivative here. We could say that h of x is just x. So we could also look at this as a composition of these three functions. The x can be composed into here, which is composed into here. Hopefully this is helpful to your studies. Cheerful calculations.